In the next few lessons, we're going to look at the phenomenon of refraction. Now, refraction happens to waves when they cross a boundary between two different mediums. Now, this can be any type of wave. For example, it can be a sound wave, a water wave, a seismic wave, or a light wave. Now, in the following lessons, we're going to look at light waves. So what actually is refraction? Well, we have a ray of light which is incident onto a boundary, and here we have a boundary between a glass plate and air, and as it crosses the boundary, the ray changes direction. Now, this changing of direction is what we call refraction. And what we're going to do in this lesson is we're going to try to understand why refraction takes place. To do this, I want you to imagine a cross-country athlete running across a field. So, what happens? Well, our athlete's running across a field that's quite hard ground, and he's running quite fast, and then suddenly he hits a patch of mud. Well, he'll immediately slow down, and he slows down because his feet interact with the mud. That's to say, the mud pulls, or the suction forces produced by the mud pull on his feet and make him run slowly. When he gets back out of the mud again, he speeds up. So what's happening is he's changing medium. He's going from the hard field to the soft mud, slows down, back to the hard field again, and speeds up. Now, exactly the same thing happens with a beam of light when it changes from one medium to another. So we have a beam of light, and it's approaching the glass block, and as soon as it hits the glass block, it starts to slow down. And it slows down because the light interacts with the glass in a similar way to the way the mud interacts with the feet of the athlete. The light gets slowed down, and then when it comes back out of the block again, it speeds up. Now, it is this slowing down effect of the light that causes it to change direction. To try and help us understand that, let's go back to our field with the mud in it. But before we do that, I want to point out something very important. Not only can we represent the light as a ray travelling like this, but we can also represent it as a wavefront, rather like water waves that you find on a beach. Okay, so you can think of the light approaching the glass block in this way. Okay, so you have a series of wavefronts, and you'll notice, and this is the important part, that if you look at this wavefront here, well, this part of the wavefront is going to hit the glass block before this part. Let's go back to our country field. Now, we've changed the athlete for a vehicle, a simple vehicle. That's an axis with two wheels on either end, and we're looking at it, the field from above. So we're looking at the plan view, and we can think of this axis as being like the wavefront of the light that we just observed. So as the wheels, or as this vehicle hits the mud head on, that's to say the direction of movement of the vehicle, that's moving in this direction, is at 90 degrees to the boundary. Well, all that's going to happen is the vehicle is just going to slow down when it hits the mud. Okay, but it's going to carry on moving in the same direction. So in this particular case, you're not going to notice any refraction or bending of the direction of motion of the vehicle. But let's have a look at, see what happens when the vehicle approaches the mud at an oblique angle. Okay, so here it comes across the field, it's moving across the field, and it's moving quite quickly, but then it hits the mud. And you notice that this wheel hits the mud first. So as soon as this wheel hits the mud, it's going to start to slow down because it's interacting with the mud. Whereas this wheel, which is still moving on the firm ground, is moving faster. Now, what's going to happen as a result of that? Well, you can imagine that the vehicle will start to bend around. because this wheel is moving faster than the wheel that's stuck in the mud. Okay, so there, like that. You'll notice that initially the vehicle was travelling in this direction up to the boundary, but when it hit the boundary, because this wheel started to move slower than this wheel, as a result of that slowing down, as a result of that interaction, the direction of motion of the vehicle changed, and it's now moving in this direction. Now exactly the same thing happens with the wavefront of light when it hits a boundary between two different materials, between two mediums. Just like the wheel axis, you'll notice that this part of the wavefront will hit the glass first, and as a result this will start to slow down, whereas this part of the wavefront is still moving through the air, and as a result there will be a change in direction of the wavefront. So initially the wave is moving in this direction, but as soon as it hits the boundary it has a new direction, it's moving in this direction, and we call this refraction. Now in the next lesson we're going to look at refraction in more detail. We're going to discover a law that describes exactly how a ray of light is bent or refracted when it passes through from one medium to another.